So the first assignment is just to make sure that we're all on the same page using source control. Source control is one of the very common tool that we use so that we can collaborate in a team, so that we have all the source code lives in one single place. We can copy down that source code down to our machines, work on it, and then put it back so that then all other folks can then bring those versions onto their local machines, right? And then we can all collaborate. And the normal process would be that there would be one particular machine that would be considered to have the master copy of the source code that eventually will be deployed, and then each one of us, whenever we're going to work on a new feature, we would create a brand new branch off of that master branch, and we would do all our work under that particular branch. Once we are comfortable with that content, we would commit and push that branch to the central repository. Okay. Then we would send a message to someone someone else in the team, and we would create a what's called a pull request, a PR, and assign that PR that looks at the difference. That PR documents the difference between what you did and what's already deployed, right? And it highlights the lines that they changed, and typically the repository would also let you know if you are in conflict, meaning that if you have written something that is inconsistent with what's already in master, okay? You would assign this to someone. Someone would review your code, would perhaps have several comments back and forth between, oh, well, why don't you use a better indentation? Why don't you add additional comments here? Instead of using a linked list, why don't you use an array list? You know, whatever comments they might have on your code, you would either reject or go ahead and apply those suggestions, and you would recommit, push a new fix, and you would have the PR would contain the pull request will contain the history of that discussion, right? That back and forth. Once you agree in the between you and the reviewer would then accept the PR and merge it into master. Okay, a notification will be sent out to the team that a new version in master is available, and each one in the team would then pull from the repository from master into whatever they're working. Each one of them will have their own feature branches, yes, and working on different features, and to make sure that they don't deviate too much from the master, right? They would then merge from the master branch onto their own feature branches, right? So that they can guarantee that they're always working with the latest source code, right? If oftentimes these processes are not followed, and oftentimes these branches, they deviate from the main branch, and the longer you wait, right, to pull and merge the latest onto your feature branch, the more deviations will be that, and by the time you're going to ask for a pull request, you'll be so far behind of how the master branch has evolved that you'll run risks of conflicts, right? That somebody went in and actually modified a piece of code that you were working on, right? Or you and just didn't know, right? They were presuming that what's in master is the latest, right? So any conflicts you want to find them as early as possible, right? And don't let the branch go off on its tangent for too long. Okay. So the first thing you would do in the morning, you come in, you're working on a feature. The first thing is that make sure you pull from master and merge into whatever you're working on, right? To make sure that you identify if there's any conflicts, and you resolve them right there and then. Okay. Once you're done on your particular branch, again, you commit the branch and assign some other team member to look over your code. Okay. The culture should be that we're all open to constructive criticism of our source code. The source code does not belong to me. I should not have any fiefdom, any personal attachment to my source code, and be unafraid of other folks, openly discussing my source code. Right, the source code belongs to the team. Right, and the pull, I would generate a pull request, assign somebody else to look at it. Right, and again, when somebody's looking at it and accepting it, they are making themselves responsible, right, and willing to own up to that source code. They are willing that at some point they might be asked to debug that same source code, just like you. It's not, if you're reviewing somebody else's code and you accept it, right, you're saying that at some point in the near future, you might be willing to debug that somebody else's source code. Okay, so Git is and not just Git, but any source control tool. It allows us to collaborate and make sure that the source code progresses towards following implementing certain requirements. Also, there's certain conventions on how we document whatever branches. The naming, for instance, the names of the branches that we choose typically follow a naming convention that is based off of the requirements. Right? Typically, when you've come up with requirements, each requirement will have unique identifiers, unique names, right? Following a particular naming convention, and the branches that you create for a particular feature will keep track of that naming, right? Of that number identifier. That any line of code you ever write, right, will be within the context of a particular requirement. You won't be writing, just code for writing code. It'll be within the context of solving a particular problem, right? This fosters traceability, so that you can see the whole life cycle of a requirement having been identified by business. This is all the documentation, UML class diagrams, sequence diagrams for that requirement, and here's all the source code, that was ever written to support that requirement, right? So you can track one requirement all the way down to these are all the 30, 40, hundreds of lines of code that we wrote to fulfill that requirement. Okay. So Git is one of many source control tools, and if you've taken a co-op or if you've used it before, you've discovered that there's many ways of doing the same thing in Git. So here we want to have a baseline and make sure that we're all doing it the same way, right? If you don't follow the instructions and the presentation of how we do certain things here, you will be deducted points. Okay, so make sure you read through. I think there's like 100 slides of how to do things in Git. So I'm only going to go through a few of them. Make sure you read the entire document, and take it as a source, as a guide, as working for this big team. Okay. So anyway, so the document, the assignment asks you to clone a Git repository that has been created for you based off of your CCS ID. If you don't have one, we're working on it to fix it so that you can have it and start working on the assignment. Hopefully, it'll be resolved in a day or so. You'll clone down this repository, and all the TAs know about these repositories. They will be policing these repositories and keeping track of the life cycle of this repository. Each one of your repositories keeps track of the how busy have you been in these repositories, and draws all these nice nifty graphs, right, of if you have been consistent, committing to these repositories, if you've been kind of pushing back and leaving everything to the end. It keeps track of all the statistics of how you've been using the drug. Typically, we would like to be able to see throughout the semester something fairly smooth, right, throughout, where you've been consistently working on small small chunks of in your assignments, right? And as opposed to these big spikes of leaving everything to the last minute. Okay, so we'll be tracking these things. The TAs will be looking. Usually, the rule of thumb is that you want to have multiple commits. Very frequent small commits, right? Every time you reach a stable version of whatever software feature you're working on, you submit it, even if it's just 2, 3, or 4 lines of code, right? It's easier to backtrack, small incremental steps than backtrack hundreds of lines of code that you've been working since yesterday, right? So it's easier to just incrementally commit multiple times a day, right? And easily be able to just back and revert some of the changes if you painted yourself in a corner. Okay? So don't let large commits get in the way of quality source code. So small and frequent commits. So these the steps that this assignment walks you through is configuring some basic configurations such as your username, your email, some URLs, some username and password for your Git, right? And then it asks you to display what some of these configurations are, then display what certain content of your configuration files are, some content of your directory, and just copy and paste them as your whatever you're gonna submit, right? For each one of these steps. Also asks you to create an ignore file. Ignore allows you to declare certain files that are not worth keeping track of, right? That you don't want to put in source control. Certainly we wouldn't want files that are either libraries or jar files, WAR files, archived files, or compressed files, or compiled files, right? None of that. Libraries, we don't want any of that, right? So in the Git Ignore, you can list all the types of files that you don't want in there, right? Or like IDE configuration files, or lots of properties files, or XML files. None of those are interesting to keep track of, okay? So you'll be listing your ignore files. We give you a link to where you can find quite a few lists of examples for Git Ignore files for different languages and infrastructures. So if you go to Java, you'll find an example of what that ignore file looks like. For instance, we don't want class files, right? We don't want log files. We don't want any of the package and archive files, zip files, EAR files. We don't want any of that. So you would add those Git ignores in there. Okay. So we don't want to see in your Git repository. We do not want to see any class files in there, right? No jar files in there. No WAR files. If we see those, you'll lose points. Okay. So make sure they do not make it to the and once you put it in there, right? There's no going back, right? Even if you remove them, right? They'll always be there, right? That there'll be a history that at some point those files were there. Right? We don't want even a history that they were even there at any point. Okay. Oops. Here we are. Then you'll be asked to create a branch, a feature branch, where you'll be creating some pieces of source codes. For instance, you'll just create a small piece of source code that takes 2 numbers and just prints out all the numbers between those 2 parameters. Trivial, something really simple. But you'll have to write it with the intent that it can be tested, right? So now it's not as trivial, right? You need to use JUnit, right, to write the source code so that it can be invoked, right, with parameters, and then it returns a response with an array, right, of values that you can then validate that indeed with this particular input, it comes back with a particular output. Yes? So you have to write it so that it's testable. Okay? And so once you've written that, you'll be asked to merge it into master. So once you have that, put it back in master. Then you'll be asked to create two branches, feature 2 and feature 3. On one of them, you'll be asked to modify now the piece of source code so that it prints only the odd numbers. Okay? And in the other feature branch, you'll be asked to only print out the even numbers. Right? So guess what? Now you have two versions of the code in two branches where you have modified exactly the same lines of code. Okay? And now you'll be asked to merge them back into master, and it's going to create a conflict. It's going to create a conflict. This is simulating two people, right, working on the same file, the same lines of code, right? It happens too often. It shouldn't happen, but it happens too often that two folks are trampling on each other's source code, okay? And you'll have to resolve it, right? And then it asks you to go through the resolution between these two branches. It'll ask you to revert one of them, right, and choose to stick with one of the features, but revert the other, and then put it back into a master branch. Okay, right. At each step, it asks you to do a listing or status or print out something to the console and copy it and paste it as your result, right, and then submit that document and post it. Commit it into GitHub, right? I believe inside of the directory homework 1, right? The TAs to grade it will visit your master branch. Will look at your solution, right, and grade you according to what you've copied and pasted into that document. Make sense? All right. All right. So that's the assignment. Now let's just go over some of the more common Git concepts and commands. Okay.